break these notes right now into two parts. Let's get started and have a look at what we're going to cover in this chapter. Chapter 2 is all about area and volume. And we're going to be looking at 3D objects as well as some two-dimensional objects. We'll start off with two-dimensional objects, and we'll understand surface area and volume. So our goals for Chapter 2 are to work with area and volume in both SI units, so perhaps meters, centimeters, and imperial units, inches, feet, yards. Later on, we're going to look at problems that involve surface area and volumes of three-dimensional objects: spheres, cones, cylinders, rectangular prisms, and pyramids. And when we're doing that, we're going to be dealing with square roots and cube roots, or squared numbers and cube numbers as well. So today we're just looking at a simple review of area, and I'm going to get you to open up your data booklet today. We're going to be looking on page 2. So in your notes here, we're looking at page 2, and page 3 also gives us a bunch of formulas. However, the formulas on page 3 are for surface area and volume of 3D shapes. So we won't deal with those today. Right now we're going to deal with two-dimensional, or what are called geometric figures. So the rectangle, the triangle, and the circle. So if you don't have your data booklet out, pause this video now and open up your data booklet to page 2 so that you have it handy. Okay. Let's go ahead and review area. So you might have already looked at some point in your life, you might have already done questions that refer to the area of a shape or the area of a geometric figure. The units of area are always in square units. And we'll look at why in just a moment. But for example, I could report the area of something in 25 centimeters squared rather than 25 centimeters. Okay, so we're going to see this little 2 right here, which tells me that that's a squared unit. Okay, squared unit. Okay, let's do an example here. I'd like to do an example of finding the area of a square. Let's say we have a square, and one of its side lengths is given to us. It's 6 centimeters. And one thing I know is true about a square is that all the sides have the exact same length. So all the sides are equal to 6 centimeters. When I find the area of the square, what I'm really asking myself is how many square units would it take to cover this square? Okay, so think of it like tiling. Imagine you had a square room and you were going to tile the room, and each one of your tiles was 1 square centimeter. Okay, how many of those tiles are going to cover that square room, cover the floor of that room? And so what we do, we have formulas in our data booklet, and I'm going to take you to the data booklet just for a moment. Oops. Okay, so I'm just going to take us to our data booklet. Let's have a look at it for a moment. We're on page 2. These geometric figures, you might want to write for yourself. These are 2D shapes, okay, two-dimensional. And I have a formula for the area. We've already used these ones for perimeter. We're now going to look at area. So we have the area of a rectangle, triangle, and circle. A rectangle and a square have the exact same formula for area, so you could add to your data booklets rectangle / square. The area is just the length times the width. Okay, in a rectangle the length is different than the width, it's longer, but in a square the length and the width happen to be the exact same. Okay, so area is equal to length times width when we're looking at a rectangle or a square. Let's go back to our notes for a moment. Okay, so I can put in right here, so I could say my width is equal to 6 centimeters, and my length is also equal to 6 centimeters. That's true for a square. And area, the formula for area is this. Area is equal to length times width. So let's do that. Length is 6 centimeters. Okay, I'll say times or multiplied by 6 centimeters. And my answer is going to come out to 6 times 6 is 36. Now my units are not centimeters. Okay, area is equal to centimeters times centimeters. That's square centimeters. So centimeters squared. And there's my answer. Area is equal to 36 centimeters squared. If you thought about what that really means on your square, if you divided the width into 6 columns, so 1, 2, 3, 4, 5, 6, and you divide the length into also 6 columns, okay, equal to a centimeter long. 1, 2, 3, 4, 5, 6. Okay, I didn't do a great job dividing them into equal lengths, but that's okay. If you now counted every one of those squares, you would have 36 squares. So it would take 36 square centimeters to cover the area of that square. And that's what your area is. But we're going to be using these formulas, okay, to help us, because we are given the formulas. So why not use them? Let's do a rectangle. I'm going to give you a rectangle that has a width. So W is 5 meters. So this is maybe a very large room rather than something small. Okay, and the length is 8 meters. So it's 5 by 8. Okay, and again, I'm going to use that same formula for area. So area is equal to the length times the width. Sometimes we use a little dot in math to represent multiplication instead of an X. And the reason we do that is we can't confuse multiplication with the symbol X, okay, which sometimes is a variable that's used to represent something that you don't know. Okay, so a dot or brackets are really great. You can also use brackets, length times width. Okay, so let's do the math. So area is equal to the length, which is 8 meters. Okay, times by the width, which is 5 meters. And my answer is going to come out to 8 times 5, which is 40. And meters times meters is meters squared. Make sure we're putting that superscript 2, that little number of 2, up in the top, okay, attached to the meters. If I don't do that, it is not the correct units. If you've got a little bit of space here, we're going to do the area of a circle. And I'm just going to go to a nice new page for a moment, but we're going to do this one next, okay? Area of a circle. Okay, so area of a circle. Okay, if I have a circle, and it looks like this. Okay. Let's say that I have a circle, and we're given the radius here. Okay, I'm going to say the radius is equal to, let's use 3 millimeters. So this is a very small circle because the radius is only 3 millimeters long. The formula that we have in our data booklet, if we go to our data booklet and have a look, the formula that you have for a circle, here's a circle, here's the formula. Now, be careful here with this formula. A is equal to pi r squared. If I'm given the diameter of a circle, I have to divide that diameter by 2 to get the radius. Remember that. Diameter is equal to 2 times the radius. Okay, or the radius is equal to half the diameter. Okay, so in this question, we're given the radius, so we can use the radius, 3 millimeters. But this little 2 attached to the r tells me I have to square the radius. So let's go ahead and do that. Let's use that formula. Okay, here's my formula. Area of a circle, A is equal to pi r squared. Another way that you can write that, okay, r squared is simply r, okay, times by itself again, r times r. So you can either square it using your calculator, or you can take the radius, which is 3, and multiply it by 3 again. Okay, there's 2 ways to do this. I'm going to show you both. So one way, okay, to calculate this is we know the radius is equal to 3 millimeters. So that's what I'm going to put in for r. Okay, 3 millimeters. And that is going to be squared. The 3, only the 3 is being squared here. Okay, so in my calculator, this is what I'm going to do in my calculator. You're going to use the button for pi. Please don't use the rounded 3.14 because the button for pi is more accurate. So you're going to put in pi. You're going to put the pi button on your calculator, okay, times. And then we're going to put in 3 And you have a couple of options on your calculator. One option, some of you guys will have a little button on your calculator that looks like this, x squared. Okay, that button means to square a number. Okay, so for example here I could say 3. Okay, and then I will simply, if you have that button on your calculator, great, I'll press it. Okay, and that will give me 3 times 3 is 9. So I should get pi times 9 and then an answer. Okay. The other button that you might have on your calculator, okay, so pi times 3, you might have a button like this on your calculator. If you don't see that x squared, you will have a little button like this. It looks like a little hat or a little arrow pointing up. And this button means exponent. Okay, so the other thing we can do here is hit that little button, and it tells us that we're going to raise 3 to an exponent. The exponent is 2, so we're going to put in a 2 here. So that 3 hat 2 means 3 squared. Okay, you want to get used to using that on your calculator. Figure out which buttons you have. Okay. The other way I could have done this in my calculator is like this. Pi, okay, times 3 millimeters. Instead of saying squared, I know that squared just means to multiply again by 3 millimeters. That's what squared means. It means multiply by that number again. Okay, so I could also put in pi times 3 times 3, so 9 pi. My answer, no matter how I compute it, should work out to be 28.3. And I need to come back and have a look at my units. My units are millimeters times millimeters, so millimeters squared. Every single time you calculate an area, you need to check that you have squared units. So whatever those units are, they should always have that 2 on them, be squared. I'm going to do one more example for you right now, which is just looking at a triangle. Okay, if you're asked to calculate the area of a triangle, because that's the only one that we don't have in our notes. So if you want to do this on a piece of paper, okay, or just maybe somewhere that you have some room on your notes, let's do the area of a triangle. Okay, I'm going to go ahead and just make one up here. So let's say we have a triangle. Okay, and on the bottom here, let's say it is 5 centimeters. Okay, and let's say that the height of this triangle, so from the top, bottom to the very tip of the triangle, let's say it is, let's see, it looks a little bit longer. Let's say it's 6 centimeters. Okay, so I'm just doing some pretty simple examples here. When you use your data booklet, you'll see that you have a triangle on page 2, and the formula for area is equal to 1/2 the base times the height. Okay, another way to write that is to say that's the same as the base times the height, all divided by 2. Okay, so what we would do here is we have to identify who is the base and who is the height. The base of your triangle is what it would sit on. Imagine this triangle is sitting on, it's only 2-dimensional, imagine it just sitting on the floor in front of you. Okay, well it sits on this part right here, it sits on the base. Okay, from the base, so here's our base. Okay, from the base to the top or the vertex of the triangle is the height. That's the height of my triangle. And so my height would be 6 centimeters. Okay, and my base would be 5 centimeters. So I can compute the area for this. It's going to be equal to the base, which is 5 centimeters. Okay, times the height, which is 6 centimeters, b times h, all divided by 2. Okay, so whatever number we get on the top here, we're going to divide it by 2. So area is equal to, well, let's do the math. 5 times 6 is 30. Okay, centimeters times centimeters is centimeters squared, and we have to divide by 2, and so we get 15 as our answer, but our units are in centimeters squared. Dividing by 2 only affects my number. I don't have any units in the bottom here, and so centimeter squares remains, and my final answer is my units.